Good morning. Well, hopefully you're watching this in the morning. These are the notes to go over 13.10, which is inverse trig functions again, which is what we did Tuesday. But this is day 2. And then you'll notice on our learning target, the added piece is just I can evaluate trig functions, but now we're going to be using a calculator. Okay, so before we were looking at nice pretty values that were on our unit circle. Today we're going to look at values that aren't on the unit circle, so we have to use our calculator to solve them. Okay. So this included just as a reminder of what our degrees and radians look like. All right, and then our warm-up, this is what we did. This is from Tuesday. Okay, so just a reminder of what we did Tuesday. Okay, so we're just evaluating the expressions. So whenever we see this inverse, it means we want to know sine of what. So sine of what angle gives us a positive root 2 over 2. Okay. Remember sine and cosine, those are our friends. We like those because I can just look at my unit circle to get those answers. Okay. So each ordered pair has an x value and a y value. Our x value is the cosine, our y value is the sine. Okay, so if I'm looking for my sine to be equal to root 2 over 2, that means I'm looking for whatever x value, but then I want my y value to be positive root 2 over 2. Okay, so this we don't care about. We want our y value to be positive root 2 over 2. So I know everything is positive up here in quadrant 1. So I know my sine is going to be positive. So I can see one of them right there. So 45 degrees. Okay, and then I know sine is positive over here in quadrant 2. So looking at just my y values, I see my other one here at 135 degrees. Okay, so sine is equal to root 2 over 2 at 45 degrees and 135 degrees. Okay, the second one we would want to know, well, where is cosine equal to root 3 over 2. So again, cosine is our x value. So cosine root 3 over 2, we have it here at 30 degrees. We also have it down here at 330. So 30 and 330. All right, tangent, those were just, we had to take that extra step because we have to look at our table first. Okay, but we have tangent, so I want to know where the tangent is equal to square root of 3. Okay, so we couldn't look at the unit circle first. We have to look here. So tangent square root of 3, that is at 60 degrees. Okay, so one of them is going to be 60. And then since it's positive, I just have to ask myself, where else is the tangent positive? Tangent is positive down here in quadrant 3. So I use that reference angle of 60 and know that's going to be 240. And if you notice, they are across from each other on a diagonal line. Okay, so that's going to be 60 and 240. Oops, too far. Okay. All right, so that's what we did Tuesday. We just looked at our unit circle. We used those nice pretty values that were on there. like I said, today we're going to move forward and we're going to use stuff that's not on the unit circle. Okay. All right. So first we have a couple like little real life examples. Then we'll move into our delta math examples. Okay. So anytime we're doing inverse trig, we're trying to find what angle we're missing. Okay. So we have a bird sitting on top of a 9.5 foot tall sunflower. And then he's going to follow this green line down to the ground. Okay. So we're going to write our own equation to find the angle of the bird's path. So it shows he's at the top of the flower. He flies to a point that's 5 feet. So he flies to down here from the base of the sunflower. And we want to know what angle he flew at. Okay. So first we have to figure out what trig function we're supposed to use. Okay. So remember we have SOHCAHTOA, because it's a right triangle here. We have our little right triangle. Okay. So if I'm talking about this angle x, first off, I know that my 5 feet here is opposite. Okay. This 9.5 feet is right next to it, so that's going to be adjacent. So that tells me we're going to use tangent. So tangent of whatever angle of theta stands for the angle we don't know, is equal to opposite over adjacent. Okay. So tangent of theta is equal to 5 over 9.5. So to find theta, we're just going to do tangent inverse of 5 divided by 9.5. Okay. All right, and then the way we do this, you'll need a calculator. Okay, so I'm using the one that's just on the computer. So you'll see right above tangent, it says tangent with the -1. So to get to that, I'm going to hit second tan. Then I'm just going to do 5 divided by 9.5. Hit enter, and that gives me my degree of 27.8. Oops. So theta is equal to 27.8 degrees. Okay. So that is the angle that the bird flew at to get to the ground. Okay. All right, we have another example here. So we're on a plane flying up at 3,000 feet. So you'll see in our picture, 3,000 feet from our plane down to the ground. When it begins its descent for landing, so it's at 30,000 feet and it needs to start making its way to the ground. The runway is 100 air miles away. Okay, and it gives us that conversion. What angle does that plane need to descend at in order to hit the runway? Okay. So first thing, I'm just going to change this 100 air miles to be in feet so that both of them are in feet. So if 1 air mile is 5,280 feet, I'm just going to multiply that by the 100, which is going to give me 528,000, oops, maybe. Okay, that'll just be there. That's okay. 528,000 feet. There we go. Okay, so again, we have to figure out what trig function we're going to use. So first, I can see that, just change colors here. If this is my angle I'm talking about, I know that this 30,000 feet is opposite. Okay, and then since this is my right angle, this is across from my right angle. I know this is my hypotenuse. Okay. Opposite and hypotenuse tells me to use sine. So sine of what is equal to opposite over hypotenuse. Okay. To solve for theta, we're going to do the sine inverse. So sine inverse of 30,000 over 528,000. Okay, that's going to give us a nice big number, but that's okay. Move it so we can see it here. So sine inverse is going to be second sine of 30,000. Make sure I type enough zeros. Divided by 528,000. Okay. We hit enter. And that gives us 3.25 degrees. Okay. So theta is equal to 3.25 degrees. So not a huge angle, but if you're on an airplane, you don't want to be descending at a huge angle anyways. Okay, you barely want to feel it. So he needs to descend at 3.25 degrees. All right, so the next two examples are more from Delta Math. So this is what your homework is going to look like. Okay, so we want to find all the angles between 0 and 360 that satisfy the equation. So we're going to find everything that would be on the unit circle. It's just not going to be a nice, pretty number. Okay. All right, so very first thing we need to do is we're going to put this in our calculator and find the reference angle. So we're going to put this in our calculator as sine inverse of 3 divided by 10. Okay, and that's going to give us, like I said, our reference angle. Okay. So let's pull up the calculator, which I closed out. Okay. All right, so like I said, we're doing sine inverse. So second sine of 3 divided by 10. Okay, that gives us a reference angle of 17.5 degrees. Okay. Using that reference angle, we now have to think, where is it positive, where is it negative? Okay. I'm talking about positive 3 over 10 here. So I'm only going to look at the quadrants where sine is positive. Okay. I have it labeled here, so A is all, everything's positive. S is sine. T is tangent. C is cosine. Okay, so that's where everything's positive. So sine is going to be positive here in quadrant 1 and here in quadrant 2. Okay, so 17.5, that's already between 0 and 90. Okay, so one of our answers is going to be 17.5. So it's positive at 17.5 degrees. The other one, if I'm over here in quadrant 2, this is where reference angles come into play. This is 17.5 as well. In order to find that, I'm going to have to take 180 and subtract 17.5. Okay, and that'll tell me where this angle is located. So 180 minus 17.5 gives me 162.5 degrees. Okay, so those would be my two answers. Okay. All right, let's look at another one. Okay. Cosine of theta is equal to negative 2/5. So in our calculator, we're going to do inverse cosine of, we're just going to do 2/5 right now. Okay. The negative will come into play when we're trying to figure out what quadrant it goes in. So our reference angle, we're going to plug it in our calculator. Okay. Oops. Clicking the wrong buttons here. Okay. So we're going to do second cosine of 2 divided by 5. Okay, and that gives us a reference angle of 66.4 degrees. Okay. But like I said, this negative here, we're only going to care about the quadrants where cosine is negative. So if it's positive in quadrant 1 and quadrant 4, that means it's going to be negative in the quadrants 2 and 3, where sine and tangent are the only things positive. Okay. So to get the one that's in quadrant 2 here, I'm going to have to do 180 minus 66.4. To get the one that's in quadrant 3, we're going past 180, so we're going to do 180 plus 66.4. Okay. Okay, so doing that math, I typed in the one down here first, so 180 plus 66.4 gives me 246.4. So that is one of them. The other one, if I do minus 180 minus 66.4, gives me 113.6. Okay. So my cosine is equal to negative 2/5 at 113.6 and at 246.4. Okay. All right, we have just two more here. Okay, so before, the ones we did on Tuesday, we didn't really like tangent. It just took us that extra step. But now that we're doing it on the calculator, doesn't matter. We're doing it on the calculator, so everything's the same. Okay. All right, so this one, we are going to put in inverse tangent of, we're just going to do the root 26 over 6. Okay, and again, that'll give us our reference angle. Then we'll worry about where it's negative. Okay. Let's pull that up so I can see it. Oops, wrong thing. So inverse tangent of the square root of 26 divided by 6 gives us a reference angle of 40.4 degrees. Okay. Now I only care about, though, where tangent is negative. So if it's positive in quadrants 1 and 3, it's going to be negative in these. Okay. So we have 40.4. So to get to the one that's in quadrant 2, I'm going to have to do 180 minus 40.4. Okay, and that gives us 139.6. Okay. To get to the one that's in quadrant 4, I'm going to have to do 360 minus 40.4. Okay. And that gives me 319.6 degrees. Okay. So remember, for reference angles, we're using the 180 and the 360. Okay. All right, last one here. Okay. Sine of theta is negative 7/9. So in our calculator, we're putting sine inverse of just 7 over 9. So we'll get our reference angle first, then worry about our signs. Okay. So second sine of 7 divided by 9 gives me a reference angle of 51.1 degrees. Okay. All right, so if I want sine to be negative, I have to ask myself, where is sine negative? Okay. So if sine is positive in 1 and 2, it's negative in 3 and 4. Okay. So here we're going past 180, so that'll be 180 plus 51.1, which is 231.1. Okay. And then over here, we would have to do 360 minus 51.1, which is 308.9. All right, and so that is what we're doing. We find our reference angle, then we have to decide what quadrant it's in for being positive, negative, and then we just add or subtract from 180 or 360, okay? All right, so for homework today, so if you go on Delta Math, there's a 13.10 assignment. Okay, just going over this. For tomorrow, for Friday, so Friday is listed as like a catch-up day, which gives you time to work on any missing assignments that you need. There's also a Google form, okay, and that will be in the Friday folder, okay, and that is already posted, okay. So the Google form is already posted. So for homework, you could do your Delta Math, and you can go ahead and do that Google form whenever you want, just because it's posted. You can get it done, and then you don't have to worry about it tomorrow. Okay, it shouldn't take you more than like 5 minutes to do. You just need to pull up your grades on campus and then answer those questions. Okay. If you have any questions about this or any of the stuff that we've been doing, just send me an email. I'm more than happy to help answer any questions. Otherwise, enjoy your weekend, and I will see you guys next week on Tuesday.